Hi, everybody. It is week 4 in astronomy, and we have a diverse and really fun week this week. First off, we're going to talk a little bit about the history of astronomy. Astronomy has been done for thousands and thousands of years because people have needed it to find and determine the seasons and be able to mark time. So we're going to look at the little bit of the history and the important characters in history. We're going to start this week and we're going to finish some of that next week. We're also going to talk about the phases of the moon, waxing, waning, crescents, third quarter, first quarter. How do we see those when all the moon's doing is orbiting the Earth? We're also going to talk a little bit about eclipses, some of the more dramatic and exciting things that you can see in the sky. So let's go over to Canvas and take an overview of what the week looks like. We're going to talk about those months and phases of the moon. Well, of course, we're going to have our study guide, eclipses, scintillation, which is twinkling, the scientific word for twinkling. We're going to get into that astronomy, begin it this week with a couple talks about some of those important characters. Our lab, of course, our weekly constellations, and then, of course, our quiz. So let's take a look at our lab. And I'm going to go to a Word document because I want to show you some specific things this week in our moon and eclipse lab. As we typically do, we're going to use a few of those simulations in that Class Action app. Go to the lunar phase simulator and grab the little character, the little fella sitting on the Earth, and you're going to rotate and move him around. And I'm going to ask you to color in the dark portion of the Earth. Now remember, if the sunlight is coming from this direction, how do I get my pen to work here? If the sunlight's coming from this direction, remember that this half of the Earth is always going to be in the dark. That's the dark side of the Earth. It's going to be night over there. So as the Earth rotates, I want you to think about what time of night or day it's going to be. So these are your choices, 12 noon, 3 p.m. mid-afternoon, and use those to fill in the chart A, B, C, D, E, F, G, H, and going from A to B to C and rotating in that direction. Then, how do you get the phases of the moon? And this is tricky because the moon, as you and I are rotating night after night around the Earth like this as it spins, the moon is going around us in its orbit. Now, keep in mind, the back half of the moon away from the sun is always dark. So I'm going to ask you to color it in. You're going to do a better job than me. I'm doing this really, really quick and dirty. But the important thing here is this circle, this big circle right here, because that circle represents what we can see. All that we can see from the Earth is we can see the light part of the moon, because if there's no light shining on it and it's dark, we can't see it. It's called dark. And the bit that's within the circle, because the circle represents what is within the range of our viewing. So this little section here that is in the circle and light, that is the phase that we see. This section here that is in the circle and light, that's the phase we see. This section is what we see. This section's what we see. And from that, hopefully you can start to come together and understand where these phases, where each one of these little phases of the moon comes from, and getting those gibbous and waxing and things like that. Then name those. Using this up here, can you name what phases you've got going on and put those down below? Here are some photos of the moon. Can you name those? And trust me, on the quiz for this week, you're going to have some photos and you're going to be asked to name phases of the moon. So you're going to have to be able to look at them and figure those out. Make sure you watch the videos and the lectures, because I've got some hints in there about waxing on and off. Moonrise and moon set. The moon rises and sets for different phases at different times of the day. So use the lunar phase simulator to assist you, plus what we've talked about in our notes and lectures. The seasons. To look at the seasons, I want you to build a small model Earth. Now, it doesn't have to be anything fancy. I did this out of a tennis ball, a couple rubber bands, and a bit of tape stuck up right there. I wrote North because this is an old nasty tennis ball, and I didn't care if I wrote on it. I've had students make these out of apples and balls of socks. It doesn't have to be anything elaborate. And this was the top of a little box. That's why I put it there, so I could take its photograph. I want you to find a small light bulb, move it around so that you can actually see how the sun hits the Earth differently depending upon spring, summer, winter, fall. And as you do this, make sure you keep one corner of your room, office, living room, wherever you're working, always keep one corner of your pretend planet aiming in the same direction of the room. And it's going to become pretty obvious looking at the shadows how the seasons actually occur on the Earth. I want you to take a selfie of yourself with your model Earth and Sun and upload this. 3 points. It's not massive, but I really want you to do this because it illustrates a lot more than just seeing a picture of where the seasons come from. Fill this little bit out. Again, we're going to go back to that class action app. I want you to look at the sun rays simulator, and this will show how the sun gets dispersed as the angle at which it hits the Earth changes. The seasons and ecliptic simulator, again, is going to look at how the sun's rays hits the Earth at different angles and how the intensity or energy of that sunlight gets spread out, and again helps us understand the seasons and how that heating works. Love this really short simulation. It's all it is a quick little 2-minute video, but these movies, or these were a series of still pictures taken from one location, University of Nebraska, every day through a year, and you actually get to see how the shadows change through the year, and they occur daily, these changes in shadow length, but because it's so subtle day to day to day, we really don't notice them very well. So watch the video, and you can manipulate it, so change it from month to month, answer the little questions, and I think it'll help a lot. Last but not least, eclipses, little eclipse simulator, draw in the various configurations for solar and lunar eclipses, answer a couple questions. So we're going to rely real heavily on our simulations this week, I guess it's a week, isn't it? Because of the fact that it's hard to simulate some of these things without some help. And so that's what we're going to do. Have a wonderful week. It's going to be kind of fun, but I think they're all fun. That's why I do this for a living. Have a grand time. Talk to you soon. Bye-bye.